Hey friends, welcome to JD's Guidance. Friends, I have come with a new video today, and this video is about the time value of money. Friends, very often we hear that there is something called discounting and something called compounding. In this video, we are going to clear all our concepts about what is time value of money and how time value of money is adjusted in order to get the real value of money by techniques called discounting and compounding. Let's begin. Friends, suppose we have 100 rupees today in year 0. I have 100 rupees, and suppose you get the same 100 rupees after 5 years. I believe that you understand that 100 rupees that you are getting today, and you got an option. There is another option that you receive it after 5 years. I'm sure that you are going to respond that you would prefer to have it in year 0 than getting it in year 5. So we always prefer to receive money early as compared to receiving money late. This is our time preference because we want to receive the money early and avoid receiving at a future date. This time preference is also known as time value of money. Now, this says that if you have received money this year, then obviously you could have invested in a bank or any institution and earned some money, and that would stand to 150 after 5 years. But if you receive it after 5 years, you are not getting that 50 rupees. So that's why there is an opportunity cost. Or in other words, this money could have been employed or used to earn some more money if you get it in year 0. But if you get it in year 5, you are not getting the chance of earning anything extra out of the money. So that's why the money that you receive at a future date, its worth is less, right? So the worth of 100 rupees today and the worth of money that you receive after 5 years, obviously the money that you receive after 5 years will carry less worth, less value. This is because of inflation. I think you all agree that 100 rupees capacity of meeting my wants is obviously be less after 5 years. So that's why the value of the money decreases. The worth of the money decreases with time, right? So that's why there is a need that if I get 100 rupees after 5 years, I need to have some calculations done in my mind to know what is its real worth at this point of time. So what I'm going to do is that this 100 rupees that I will receive in future, I'm going to find its true value at this point of time, and this technique that we do is called discounting. So I will do some kind of discounting, and after discounting I will find out its true value that we will get after 5 years, not going to 5 year, but I am still in year 0 and trying to know its value after 5 years. So its value would stand to, say for example, 98. That means 100 rupees worth money today is 100, but after 5 years its value will be 98. That means the money value is reducing, or in other words, it is discounted. Okay, very often we need to take decisions where we have to make evaluation of what would be the present value of some money that we will receive in future. Sometimes we take up insurance policies, or we take up bank deposits, or invest in any investment institutions, and we have an assurance that we will receive 50,000 after 10 years or 15 years, and we become happy. We should not become happy so much, because 50,000 that you will receive after 10-15 years, its true worth has to be ascertained, because by the time we reach 10th or 15th year, its value has almost reduced. So that's why we need to have the evaluation done from the perspective of its present worth, its worth, real worth, right? This is done through discounting. This is one story. The another story is that sometimes you invest money in banks, and say for example you have invested sum of rupees 10,000, and the banks or any institutions, you have kept this money for, say for example, 5 years. Year 0 you have kept 10,000, and after 5 years you will receive the money back with some amount of interest added to it. You want to know what is the value that you will receive after 5 years. This is because 10,000 will of course add with itself some amount of interest, and this interest generally is compounded. It can be a simple interest or it can be a compound interest. So obviously it will be 10,000 plus some more money and that is the interest money that will be added. So that means this money value has increased because of interest. So this technique to know what will be the future value of money, here we are trying to know the present value of money, because the value of money will reduce. So we want to know at present day if it is, what is its worth after 5 years. So it is 98 in my example. Similarly, you have kept 10,000, you will receive after 5 years. So after 5 years, its value would be 10,000, say it will become 11,000. So 1,000 has been added as interest. So you are trying to know the future value, and the technique that you used is called compounding technique. Okay, so this is the concept of discounting, and this is the concept of compounding. But as I told you in my example, 100 becomes 98. How did I know, or what is the calculation that takes place? We are going to see that. Also, if 10,000 becomes 11,000, how did I get 1,000? That also we have to know. For this, there are two ways. One is that you use some formulas and get the value. The other one is that you refer to tables. If you refer to table, calculations will be very simple, but you also need to know the formula, so that if at all you don't have a table, or you want to know the fundamentals behind, you can know it. So let's see both the things, finding out the present value by doing some formulas, and also by referring to table, also knowing the future value through formulas and table. Let's begin. Friends, we are talking about, first we are talking about discounting. Okay, so you know, in discounting what we are doing is that we are trying to know the present value of future cash inflows. I repeat again, we are trying to know the present value. We want to know the present value of future cash inflows. So discounting is done, as the word itself tells, that it is discounting. You will receive some money in future, I will discount it at a rate and find out its true value. Okay, then you want to know the compounding technique, and compounding is done in order to know the future value of cash inflows. You are supposed to receive some money in future, what is its value in future, you want to compute. So this is known as future value of cash inflows. So these two things we will do here. Now I will take up some cases, because the formulas will change depending on the case. So I will take case A for a single cash flow. Single cash flow. Now suppose a person is investing 100 rupees in year 0, and he invests it for 5 years, say year 5, he wants to know what is its future value, right? I have invested 100 today, and I've kept this money for 5 years, and I want to know what would its value turn out after 5 years, given that the rate of interest is 10%. So how will I do this? There is a formula. So future value is equals to present value times 1 plus r to the power n. Now if you put it in the formula, what is my present value? 100. You multiply with 1 plus 0.10 and raise it for 5 years, because this example is for 5 years. So this 1 plus r to the power n is the compounding factor. This is the compounding factor with which you multiply the present value, you get the future value of the cash flow. Now this factor is using formula. Without using formula, you can refer table and do it. I will show you. Now in my example, if you calculate, what would be the answer, we will see. Now similarly, if you want to know the present value, if a person has, if the case will be different, if you think that in future you are receiving 100 rupees, and you want to know what is the worth of this 100 rupees at this point of time, given the discounting factor is 10%. This was interest factor, and this is the discounting rate. The discounting rate is 10%. So the same formula, but I'll see future value is already there, present value is there. From the same formula, I will do some inverse. So what is present value? This divided by this. So future value divided by 1 plus r to the power n. So in my example, future value is 100. If I divide by 1 plus 0.10 to the power 5, I will get what will be the present worth of this 100 rupees that you are likely to receive after 5 years. Friends, here I said this is the compounding factor, and if you notice here, this is 1 by 1 plus 0.10 to the power 5, or 1 by 1 plus r to the power n. This 1 plus 1 by 1 plus 1 to the power n is the discounting factor. This is the compounding factor, this is the discounting factor. The same thing can be identified with the help of table that we will see. Now let's compute what would be its value. I will take the help of a calculator and find what is its value. So friends, I will just raise this 1.10 to the power, I will raise it to the power 5, and then we see the factor is coming 100 into 1.611, and so if I multiply this with 100, I get 161.05. That means my future value of 100 rupees, if I get 10% interest compounded, then it will be 161 after 5 years. Now let's do this. I will just find out. So this will be 100 divided by 1.611. So it will be 100 divided by 1.611. So I get here the value is, this is rupees 62.073. That means after 5 years, if you receive 100 rupees, its value is, or its worth is actually 62.073. So friends, this was the first case of a single cash flow. Now, I want to tell you that sometimes what happens, this is a case when you are getting the interest here, which is compounded annually. Okay, interest is compounded annually, but sometimes and discounting is done annually. Okay, now because 5 years you have invested this money, so every year your interest will be compounded. Here also every year the discounting will be done. Now question is, sometimes the banks are giving you interest in 2 times in a year, or you can say half yearly interest. Sometimes they give you quarterly interest, right? So in this case, this future value has to be, this formula has to be modified. Similarly, you are doing annually the discounts. Okay, now sometimes this discounting has to be done more than once in a year. Like interest is received more than once, here in discounting is done for more than once in a year. If this is the case, I'm writing case B, where there is multiple cash flows, or you can say interest, compounded more than once in a year. If it is more than once in a year, or in case of interest, it can be a discounted more than, when it will be discounted, when you are ascertaining the present value, when it will be compounded, when you are ascertaining the future value. So what is the formula of future value? If interest is compounded for more than once in a year, same formula I'm using, PV into 1 plus R will be divided by M, and here N will be multiplied with M. What is M? M is the number of times compounded, or you can say number of compounds. Okay, so suppose in my example, you are getting 10% interest given on a half yearly basis. Means if you have invested for 5 years, 10% interest, so in 5 years there will be 10 times you will be getting interest, because once in a year, 1 year you will get 2 times. So in 5 years you will get 10 times. So I will just alter the formula. So present value for 100 rupees, future value of 100 rupees, 1 plus 10% is the rate of interest. How many times interest is received? Twice in a year. If it is 4 times, you will write 4 times in a year, into what is the number of years for 5 years? How many times? Twice in a year. If you simplify, you will get the future value. Similarly, for present value also, my dear friends, you can notice the formula is FB, future value, by 1 plus R to the power n. So now if you are discounting for more than once in a year, the formula needs to be changed. So 1 plus R divided by M divided by my exponent, you write N into M. Okay, so in my example, what is the present value of 100 rupees that you will receive after 5 years at the rate of 10%? If it is compounded twice in a year, then the formula will be like this. Remember, M is equal to number of times discounted. times discounted. So if I put in the formula the values I will get. So I'll again take use of calculator and see what is the value of 100 rupees. What is the value of 100 rupees if interest is given twice in a year? So 0.10 divided by 2 plus 1. You raise this to the power 10 times. So ultimately your factor is, this factor is 1.63. So this will be 100, I'm writing it here, 100 into 1.63. So you just multiply this with 100. So you will get rupees 162.89. Similarly, if you do this, you will find 100 divided by 1.63, you will receive 61.35. So this is how, if interest is compounded half yearly, and this is discounted half yearly, and this is interest compounded half yearly. Let me just cross check again the calculations. So 0.10 divided by 2 comes to 0.05. I add plus 1 and I raise it to the power 10. So if I raise it to the power 10, so if I raise it to the power 10, just 1 minute, I repeat what I have done. So 1 plus, sorry, it will be 0.10 divided by 2 plus 1, and then you raise this to the power, 10. So what you get is 1.63, and you multiply with 100, you will get this much. Similar is the case, this is discounted, so you get this much, right? So you are getting a case where the cash flows are compounded half yearly or quarterly. This would be the formula. Let's take up another case. And this case is quite common when you do get sums on compounding and discounting. Okay, let's thoroughly understand this. The third case is when you are getting mixed stream of cash flows. Case 3, when stream of cash flows are mixed. Case C, mixed stream of cash flows. Stream of cash flows. Friends, I'll just give you one example and very quickly you can follow this. Suppose in year 1 you are receiving 500 rupees. Year 2 you are receiving say 550 rupees. And year 3 you are receiving 600 rupees. Year 4 you are receiving 700 rupees. So here your money that you are getting is not the same, and it is coming at a regular point of time. So year 1, year 2, year 3, year 4, it is not the same as we have done last, right? In the last case there was only 100 rupees after 5 years, or after 5 years 100 rupees present value. But here you are getting different cash flows coming at different points of time, and you are supposed to know the present value of the entire cash flows. Now if this is the case, what will you do? Very simple. You can find out the present value of 500 rupees, present value of 550, that will come after 2 years, present value of 600, that will come after 3 years, present value of 700, that will come after 4 years. This way you can do. So what we are doing is that actually you are trying to know what is the future value. First let us find out what is the future value. I want to know the value of cash that comes after 1 year. So I'll write present value into 1 plus r to the present value of year 1, 1 plus r to the power 1, plus present value of year 2 plus into 1 plus r to the power 2, plus present value of year 3 into 1 plus r to the power 3, plus present value of year 4 into 1 plus r to the power 4, plus it can be for many years, present value of n year 1 plus r to the power n years. Now if I have to put it in the formula, so what it will be? It will be future value of 500. So I'll write present value is 500. Sorry, future value for the cash which comes to you after 1 year. What is the future value? You want to know future value of 500. Okay, that comes to you just the next year. I want to know what is the value of 500 just the next year, right? So present value will be 500, you will write 500 here. 550 you will write in the second year, 600 you will write in the third year, and 700 in the fourth year. Now 1 plus r to the power, r is say rate of interest 0.10. This is coming in which year? The next year. So raised to the power 1. Second one, it is coming next to next year. So raised to the power 2. Okay. This way you will compute to know the future value of cash. Now here you have to understand that in question what they are asking. In the situation where it is mentioned that you are receiving 500 the next year, you are receiving 550 in the second year, you are receiving 600 the third year. So you are trying to find out the future values, because here the future is just the next year. Here the future is next to next year. This way you will have to find out, right? Now if I have to write it in a simple notation, what we are doing, sigma I is equals to, I can write sigma I is equals to 1 to t period. T is the unlimited period. All the cash flows 80, present value of 80, all the present values I am writing 80 into 1 plus r to the power t. So this is the formula that you do for future value. Similarly, for present value, what we are doing, we want to know what is the present worth of 500 that will come the next year. What is the present worth of 550 which will come second year. Present worth of 600 that comes the third year, right? So here, what is the present value formula? Present value is future value of period 1 divided by 1 plus r to the power 1 plus future value of year 2 plus 1 plus r to the power 2. Likewise, future value of nth period by 1 plus r to the power n. So if I put it in a notation, I is equals to 1 to t, and you can write all the values of cash flows as AT divided by 1 plus r to the power t. So what we are doing, we are discounting the cash flow that I am receiving in the second year with a rate, this one, raised to the power 1, because you are finding out for the next year, raised to the power 2 for the next to next year. Now, depending on the situation, sometimes the question asks for, in case of future value, friends, there is a chance that you make mistake. Here, in my example, I am saying that a person is receiving 500, 550, 600, 700 in the years. So you want to know the future value. So quite logical that I find out the present worth of a future value is equals to present value, that is 500, 1 plus r to the power 1. Now suppose I want to know that it is coming after 1 year. But suppose you have kept the money year 1 500, year 2 550, year 3 600, year 4 700. This way you have kept the money. Now, and after year 5, you are at the beginning of year 5, you are getting all the monies. You want to know what is the future value. Now this year 1 you have kept 400, 500. For how many years you are keeping? For 4 years you are keeping. So you will write raised to the power 4. 550 you are keeping for how many years? For 3 years, raised to the power 3. 2, 1, this way. Okay, so it depends on the question what they are asking. If some person is keeping money this to get some huge money after 5th year, then the future value will include present value into 1 plus r to the power, means you are trying to know after 4 years what is its value, after 3 years what is its value, what after 2 years what is its value, after the last year, that is first year, what is its value. Okay, this way you have to calculate. Friends, you can see the table where the title of the table is shown as see the present value of 1 rupee. Now when you have this table, means present value of 1 rupee means you are trying to do the discounting. When you have this table, first thing, as I told you, you have to refer to R and N. R is the rate of interest. So in my example, the rate of interest was 10%. So you go to 10%. Right? So you can see there are some percentage given on the column heading. Okay, and I will go to 10%, and we have to know N. N is how many years. So if you see, the number of years is coming in the left side. See, you can see it is given years. So I will find out for 5th year what is the rate of, what is the discounting factor at the rate of 10%. Friends, if you see, if you check the discounting factor for 10% for 5 years, 1 2 3 4 5 is 0.621. It is 0.621. right? So this is the present value factor, or in other words, the discounting factor. If 1 rupee you have to discount, this is the factor. Now let's talk about the future value. For future value, you will refer to the future value table. You can see the table name is compound value of 1 rupee. That means your compound value means future value, okay, because the amount of interest is compounded. So compound value of 1 rupee. Now how will you find out? You have to first find out the rate of interest. So in my example, the rate of interest is 10%, and you will take it for 5 years. So 1 2 3 4 5, it is 1.611. So this is the compounding factor. This is the compounding factor for 1 rupee of money. With this you will compound your 100 rupees, 500 rupees, whatever is in the question or situation, you will find out the compound value. Okay, and if you need clarifications, I would definitely respond. Friends, we will meet again with another case which is very important. This is the case of annuity, and I hope you will watch my next video on annuity. So till then, bye bye, take care.